Okay, welcome to screencast number 5 from Chapter 18, Global Climate Change. We left off getting ready to talk about the current and future trends and the impacts of climate change. And as we can surmise from what we've studied so far, climate change has had major impacts on organisms, ecosystems, and human well-being. We have seen the effects on coral reefs as one of the biggest examples of what we've looked at today in the change. Scientists have studied so much of climate change. They have taken in many variables. It continues to be monitored. They're building long-term databases, not only for researchers today to study, but future researchers to have that data bank to be able to go back and reference. And there is a ton of scientific literature that has been published as a result of these studies. A lot of this research has been used to help develop policies. They're used for our government to try to understand and to develop programs. So one of the programs that was developed is the Intergovernmental Panel on Climate Change, the IPCC, and this was established in 1988 by the UN, along with the World Meteorological Organization. It is composed of hundreds of international scientists, not just scientists from the United States, but from around the world, and many government representatives also from around the world as well. And what it does is it publishes assessments that have been done on climate change within certain periods on the world as a whole. And the IPCC just released in 2007 its fourth assessment report. And this report summarizes all of the scientific studies that have been conducted. So in the IPCC's fourth assessment, it documented observed trends in surface temperature of the Earth. It took a look at precipitation patterns, snow and ice cover over the planet, measured sea levels, recorded storm intensity, and looked at other factors. One of the reasons for having this report is its ability to predict future changes in the phenomena after considering the range of potential scenarios for future greenhouse emissions that were collected. It also addressed impacts of the current and future climate change on wildlife, ecosystems, and society. And it discussed strategies that might be pursued in response to climate change. There is a little bit of uncertainty with this, as there is with most scientific study. Even though the authors took great care to assign statistical probabilities to their conclusions and predictions, they did their estimates in a very conservative manner. Because its scientific conclusions need to be approved by representatives of the world and nations. So they didn't want to scare them with these huge drastic predictions that they were having. What they found out, though, from 2010 is many of the aspects of climate change have grown more severe and faster than they predicted, and they underestimated many of the changes. So, as the world continues to monitor the model of climate change, researchers got together and completed the fifth assessment report faster than they ever had. They looked at from the years of 2013 to 2014, and they continued to see an increase. This is reported. What I would like you to do is Google search it and download and look at some of these new reports. They're not available when this book was published, but you'll be able to explore some of the research and findings. So please make sure that you do that, okay? This data table 18.2 is the observed and predicted trends and impacts of climate change from the IPCC's fourth assessment report. It looks at the global physical indicators. I know this is a little bit hard to see on the screen, but if you have your textbook, it's found on page 493. You can pause this and then get your textbook so that you can follow along with this. I'm sure you took it home with you. So what they saw is that the average surface temperature increased by 0.74 degrees Celsius. So what that means in terms of Fahrenheit for you and me, that's about 1.33 degrees Fahrenheit. So that's significant. I keep going back to the example of 32 degrees is freezing, 33 degrees is going to be melting. So that's a big difference. So this change over the past was the change recorded over the past 100 years, and they're predicting a 3.2 to 7.2 degree Fahrenheit change in the 21st century. The oceans absorbed about 80% of the heat from the climate systems, and it warmed the depths to about 9,800 feet. The glaciers and the snow-covered ice caps and ice sheets and sea ice are melting, and they are contributing to sea level rise. We're seeing that sea level rose by 7 inches in the 20th century, and we're looking for another 7 to 23 inches in the 21st century. The pH of the water, ocean water, became more acidic, and it's going to continue to become more acidic. The storm surges has increased. We're seeing more level 4, level 5 hurricanes, and we're seeing carbon uptake by our terrestrial ecosystems peaking by the mid-century, and this is going to weaken or reverse, might even amplify climate change. So regional physical indicators showing that the Arctic seas are warmed the fastest because they no longer have the ice to reflect that heat. The temperature, this has caused the ice to thin by 7.4% since 1978. Precipitation is going to increase at high latitudes and decrease at subtropical latitudes, making wet areas wetter and dry ones drier. The droughts are becoming longer and more intense and more widespread since the 70s. We're going to see droughts in some areas, and flooding will increase, and this will all lead to agricultural loss. The social indicators, farmers and foresters have had to adapt to alter growing seasons and disturbances within their regular routines. The temperate zone crop yields will rise until 5.4 degrees Fahrenheit of warming. And then in dry tropics and subtropics, the crop productivity will fail. So we're looking at areas like Mexico and Costa Rica and South America and parts of Africa. We're going to see impacts on biodiversity. This is going to cause a change and loss of food, water, and other ecosystem goods and services. The rise of sea level will displace people from island and the coast. The melting of mountain glaciers will reduce water supplies for millions of people. The economic costs are going to outweigh the benefits. The cost could average 1 to 5% globally as a result of the warming. The poorer nations and communities will suffer more, and human health is going to suffer with the warm weather, health hazards, and decreased cold weather, because that means that bacteria and viruses are going to be able to thrive and flourish. So our biological indicators say that species range are shifting towards the poles and upward in elevation, and they will continue to shift. The timing of seasonal phenomena, such as migration and breeding, is going to shift as well. We're going to see about 20 to 30% of the species could face extinction. The coral reefs are going to suffer further bleaching as the ocean continues to acidify. So this is what the research is showing. And keep in mind, this is a conservative model. So we do have to be concerned with the temperature. The average temperatures of the Earth have increased by 1.6 degrees Fahrenheit in the past 100 years. Most of this increase has occurred within the past few decades. The last two have seen the highest temperatures recorded as far as our seasons are concerned. So that means the number of hot days have increased. The 18 warmest years on record occurred from 1990 to the present. From 1991 to 2000, most areas of the United States experienced a temperature increase of more than 1 degree Fahrenheit. Okay, so summarizing all of this, we're seeing that in the past 100 years, a temperature increase of 1.6 degrees Fahrenheit. And most of this change has happened over the last decades, with the last 18 years being the warmest that have been recorded since 1990. And from 1991 to 2000, most areas of the United States experienced an increased temperature of more than 1 degree Fahrenheit. We're looking at the next 20 years at increasing by 0.7 degrees Fahrenheit, and by the year 2100, the IPCC is predicting that temperatures will increase by 3.2 to 7.2 degrees Fahrenheit. Obviously, this is going to vary from region to region, and that's why the large span in the prediction. So when we look at our global temperature, the way it's been measured since 1880, look at the way our trends are going here. In A, this shows the changes in the Earth's average surface temperature that you're seeing. Since 1976, every single year has been warmer than the average. So we're looking, right around this area and see how it has been increasing in warmth from that. And then when we look at this graphic, this is proxy indicators. The blue line is the thermometer, the blue line is the proxy indicators, and the red line is the thermometer data, and they show the average temperatures in the northern hemisphere over the past 1,000 years. The gray shaded zone represents the 95% confidence range that they have in the recording of this data. And here's where the biggest change has been. So taking a look at this graphic in temperatures, the change in degrees Fahrenheit that you're seeing with this, some areas of the Southwest cooled, as you can see, slightly, but most of the nation warmed by more than 1 degree. So the darker areas show that warming trend. So the South is getting a little bit cooler, and they've seen more snow in the past few years because of that cooling. And this is the region we live in, and we're seeing an increase of about 1.5 degrees temperature shift. So now this graphic is showing how the land masses are expected to warm more than the oceans, and the Arctic will warm the most, as you can see by the darker shades. This map was generated using an intermediate emission scenario involving the average global temperature rise of 5.0 degrees Fahrenheit by the year 2100. Okay, we're running out of time for this screencast, so we'll pick up on the next one at this point. See you on the other side.